So hello everyone, and here we are with the first example for the tutorial for the clutches and the brake. So for this example, we have the assembly shown below is to be started by a brake from the 775 RPM to 0 RPM in less than 0.5 seconds or less. Okay, so the following data were used to compute the required brake torque. Find the torque. So for the calculation of the WK square, you'll need to go back to the book and have a look at the chapter 22 for the calculation for the K and the WK square, which is mainly going to be about the weight multiplied by the K, which is the radius of gyration, if you remember it, in from the machine and mechanism subject, the A, I think. So to calculate the time required to accelerate or decelerate the load can be found by first find the moment of the inertia for every single parts, then divided by the mass on the square root, you will find the radius of gyration. Then you know the W, which is the weight, and you're going to find the value for WK square. That's it. So to calculate the torque, this will be the equation. That's for the SI unit. Sorry, for the IP unit. For the SI unit, you just need to find the delta N to be in radian per second, and the WK square is going to be in the units of Newton meter square. Sorry for that. Newton meter square. And the 308, which is the feet second square, you can change it to a meter second square of 9.81. Time is going to be always in seconds. So you're going to find the torque in Newton meter. So the calculation for the WK square for different types of the machinery can be given. For example, you can do this example. You can have a look about how they done the thing. So you can see they start to calculate for the gear A, for the gear B, for the shaft, for the other parts until you're going to have the total WKA square. And then they use it with the known torques to find the time for the stopping. Here we're going to use it to find the torque. So this will be the equation we're going to use, the one at the top. And this table has been already calculated for us, so you don't have to calculate it. And WK total is 4.998 Newton meter square. So we will go for the solution. We know the WK square, the total one. Wn was 775 Newton radian per revolution per minute, minus 0, because we're not going to slow it down, we're going to stop it. And then we multiply by pi divided by 30 to make it in radian per second. So we have 82.57 radian per second. The time is 0.5 second. Now we're going to bring back the equation. WK square is known, Wn is known, the time is known, and we're going to put the parameters in, and the torque will be equal to 81.143 Newton meter. Okay, so once again, that's why we have the book. You can go back to it, read further about the topic, and this will be all useful for you in the future. Okay, we're going to do the question number 2 in a separate